Hi everyone! Today, me and my friends, we are going to presenting about sodium. Sodium, what is sodium? Well, sodium is a chemical element with the symbol Na and atomic number is 11. Sodium, it is highly reactive metal that is commonly found in everyday compounds such as table salt. My name is Aina Sofia binti Jamal, and in this presentation, I will explain the physical and chemical properties of sodium. Alright, first, let's take a look at the physical properties of sodium. Well, sodium is a soft metal, which means it can cut easily with a knife. Has a silvery color and looks shiny when freshly cut, but it quickly turns dull when exposed to the air. Besides that, sodium has a low density, so it can float on water, and it also has a low melting point, which is about 98 degrees Celsius. Well, like most metal, sodium is a good conductor of heat and electricity. Next, I will explain the chemical properties of sodium. Sodium is highly reactive metal, especially with water. When sodium reacts with water, it produces sodium hydroxide and hydrogen gas. This reaction can sometimes cause a flame. Sodium also burns in air with a bright yellow flame. In chemical reaction, sodium loses one electron to form positive ion called Na+. Because of this, sodium forms ionic compounds such as sodium chloride. In conclusion, sodium is a soft and low density metal with high reactivity, especially with water and air. Thank you for listening this part, and I hope you stay tuned until the end of this video.
Hi everyone, my name is Ivy Melissa. Today I would like to explain about electron configuration of sodium. Sodium is a chemical element with the symbol Na and atomic number 11. This means a natural sodium atom has 11 electrons. The electrons are arranged in energy levels, starting from the lowest energy levels closest to the nucleus. The first energy levels can hold to maximum 2 electrons. So sodium places 2 electrons go into the first shells. The second energy levels hold 8 electrons. So 8 electrons go into the second shells. So the remaining 1 electrons goes into the third shells. Therefore, the electron arrangements of sodium is 281. These arrangements can also be written in orbital notations as 1s2, 2s2, 2p6, 3s1, and also can be shown by draw orbital diagram. The 1 electron in outermost shells is called valence electrons. These single valence electrons make sodium very reactive and places it in group 1. The valence electron in electron configuration of sodium is 3s1. So in conclusion, sodium electron configuration explains its chemical behavior and high reactivity. That's all from me. Thank you.
Hello, my name is Elizabeth Reka, and I will explain the chemical bondings of sodium. First and foremost, sodium primarily forms ionic bonds. As we all know, Ionic bonds is a bond in which an atom donates one or more electrons to another atom to produce ions. The ionic bond is also defined as the electrostatic force of attraction between positively charged metal ion and a negatively charged non-metal ion. Since sodium has one valence electron, it needs to lose or donate that electron to achieve a stable electron configuration and create an ionic compound. For example, chlorine is a negatively charged non-metal ion and it needs only one electron to complete its outer shell. In this case, sodium will give away its valence electron and chlorine will accept that electron. At the same time, sodium ion will become positively charged, known as cation, whereas chlorine ion will become negatively charged, known as anion. All of this process create an ionic compound called sodium chloride, or commonly known as table salt. Another chemical bond sodium can form is metallic bond. This bond occurs inside a pure sodium metal, where sodium atoms are held together. As for the valence electron inside each sodium atoms, that electron moves freely throughout the entire structure, forming a sea of electrons. Lastly, sodium can bond with carbon. For example, sodium cyclopentadienide and Ac5H5, forming a highly polar bonds where carbon acts like a carbanion. This bond is known as the polar covalent bond. To simplify, sodium can form three bonds, most commonly the ionic bond, second, metallic bond, and lastly, the polar covalent bond.
Right now, let me and my friends briefly explain to you guys the daily life use and industrial application of sodium. Let me start first. One specific daily life use sodium is in table salt. Sodium is not used alone. It combines with chlorine to form a sodium chloride, which is common salt. In our daily life, table salt is used to season food and improve taste. It's also important for food preservation because salt helps prevent the growth of bacteria. Besides that, sodium in salt is essential for human body as it helps control nerve signal and muscle movement. Therefore, sodium plays an important role in daily life through the use of table salt. One important industrial application of sodium is in the production of sodium hydroxide. Sodium hydroxide is produced through the chlor-alkali process. For your information, in industry, sodium hydroxide is widely used in manufacture of soap and in detergents. It is also used in paper and pulp industry and water treatment. This shows that sodium plays an important role in many industrial processes.
So, for my part, I will explain specific daily life or industrial applications of sodium in makeup and cosmetic, also in beauty products. For makeup and cosmetic, sodium hydroxide and sodium citrate are used in very small amounts in cosmetic products to control pH and maintain the pH level. Maintaining the correct pH level is important because it helps to ensure that makeup products are gentle and safe for the skin.
Sodiums are also widely used in medical fields. Sodium are primarily from sodium chloride, which is essential for maintaining fluid balance, nerve signals, and muscle functions in the body. One of the medical applications is intravenous saline, or commonly known as IV saline. Normal saline contains 0.9% of sodium chloride solution, and those are used to treat dehydration, fluid loss, and electrolyte imbalance. Another medical application is hyponatremia treatment. Prescription sodium tablets are used to treat low blood sodium levels in patients. Sodium acts as an inactive ingredient in many medications. For example, effervescent and soluble drugs. These are often contain sodium bicarbonate to create fizz and help the tablet dissolve in liquid, which are mainly water, which can result in a high sodium content per dose. There are also some other common high sodium medicines, which are painkillers like paracetamol and crocodamol. Although sodium itself is essential for the body, but it must be consumed in moderation. Excessive intake will cause hypertension, also known as high blood pressure, heart disease, strokes, and kidney disease. Hence, sodium has both benefit and disadvantage to the human body.